Hello everyone, this is Nagarjun CM from Sri Krishna Coaching Center, Channapatna. Today I would like to explain one important concept which is there in 9th standard Science chapter 2, that is Tyndall effect. To know about this Tyndall effect, first we have to understand what is the meaning of scattering of light. The deviation of beam of light from a single path into different directions when there are some interactions, or when a beam of light which is coming in a single direction, when it comes in contact with some particles, it deviates in different directions. So this is known as scattering of light. Okay, now I will tell you what is the meaning of Tyndall effect. Tyndall effect is the phenomenon of scattering of light when it is passed through a colloidal solution or a fine suspension. So this is called as Tyndall effect. Here I have written three kinds of substances, or we can call it as mixtures. First one is known as solution, second one is colloid, and third one is suspension. We know that the solution means it is the mixture of two or more pure substances. That mixture is called as solution. The components of solutions are, first one is solute and another one is solvent. These are the main two components of solution. We know that one very well. Okay, so now when we add salt into the water, that becomes solution. Here salt is the solute which will be dissolved in solvent called as water. Okay, now when we add the salt and when we stir it properly, the salt will dissolve completely within a short span of time. Solute will dissolve completely within a short span of time and it will not settle down. This is called as homogeneous mixture or homogeneous solution. The type of solution here is homogeneous because we can find the same composition throughout this solution because of uniform dissolving of solute, or what we can call it as a salt now. And here the size of the solute is less than 1 nanometer, which will be equal to 10 power minus 9 meter. In case of solution, the filtration is not possible because the size of the particles are very less. When we take small size filter like this and when we pour this solution, the solute which is already dissolved, that one also pass through this filter, so that we can't collect the solute separately once after mixing. That means filtration is not possible in case of solution. Another important thing is Tyndall effect. Tyndall effect cannot be observed in case of solution. That means we can't see the scattering of light. Beam of light is not visible in this solution. Now coming to this second one, that is colloid. Colloid means here the size of the solute is in between 1 nanometer to 100 nanometer. That is known as colloid. When we mix such kind of solute into the solvent, it becomes colloid. For example, when we add some milk to the water, so that is colloid. Similarly, if I add Dettol into the water, that becomes colloid, where the particle sizes are in this range. In case of colloid, the particles of the solute dissolves very slowly. Here it is heterogeneous mixture. Okay, So it dissolves very slowly and that means it settles down very slowly. In colloids, the size of the solute particles is greater than that of the solute particles in solution, but here also filtration is not possible. We can't separate the particles of the solute from the solvent in case of colloid also. But we have one method called as centrifugation. By using this method, we can separate the solute particles or the filtration is possible. And another important thing is we can observe Tyndall effect in case of colloid very clearly. We can see the path of light through this solution. Okay, this is one more important thing. The next one is suspension. In case of suspension, the size of the solute particles is greater than 100 nanometer. When it is greater than 100 nanometer, then here the particles will settle down very quickly. So, the particles of the solute will settle down very quickly. In case of colloid, the particles will settle down very slowly, but in this case the solute particles very quickly they will come and they will come to rest position at the bottom. Okay, now this is also heterogeneous mixture. In case of suspension and colloid, we will get heterogeneous mixture, but in case of solution, we will get homogeneous mixture. And coming to the filtration, filtration is possible in case of suspension also because the size of the particles are greater than 100 nanometer. Suppose for example, when I add some clay particles into water, the particle size of the mud or clay is greater than these two things, colloid and solution. Because of this large size, we can easily filter those solute particles. Okay, the solute particles will be collected on the surface of filter. Here that filtration is possible. And one more important thing is here also we can observe Tyndall effect. Scattering of light is possible here also, but this medium is not transparent. We can clearly see the path of light in case of colloid only. We can't see the path of light in solution. Here in suspension we can see that, but it is not clear because of greater size of solute particles. Now let us demonstrate this experiment by using some required materials. This is the solution where I have taken water as the solvent and I have mixed salt, which is the solute, and salt, it has been already dissolved and we are seeing that solution now. In another glass I have taken some water and then I added some Dettol, some drops of Dettol. Now it is an example for colloid. Similarly, we can add milk also in order to get colloid. This is one more thing. In this glass I have taken some water and I added mud particles. So the size of the solute is slightly large, so it is greater than 100 nanometer here. Now let us see in which case we can observe Tyndall effect clearly. This is the solution consisting of salt as the solute and water as the solvent. After adding salt, I kept it for some time so that the salt completely dissolves in water. Now I am having one laser beam. So when I pass this laser beam, see this, the laser beam is visible on the wall, but the path of laser beam is not visible through this medium or through the solution. The path of laser beam is not visible. It is visible only on the other end, that means wall. Okay, That means there is no Tyndall effect in case of solution. I will replace this solution with colloid. Initially, I added some droplets of Dettol into this water. Here, the Dettol particles are solutes and water acts like a solvent. Now, when I pass the laser beam, we can observe that the path of light here. See here? So, this is the path of light which is visible for us. Here, scattering of light takes place very clearly, and hence we are able to see that path of light. Which is not possible in case of solution. Now I will take one more thing, that is suspension. So this is the suspension. In this suspension, the particle size, the solute particles sizes are very more or very large. Okay, so now if I pass the laser light here, here also we can see the path of light. We are able to see that path of light here also. That means Tyndall effect will be observed only in case of, it is clearly observed in case of colloid, and we can also notice the same thing in case of suspension. But in colloid, it will be clearly observed. Scattering of light takes place, which is known as Tyndall effect. Thanks for watching.